Hello and welcome to my video explaining the chemical and therapeutic importance of isomerism. Whenever isomers are involved in industrial applications, it is mostly associated with the development of singular amounts of enantiomers within chiral drugs, which are known for chiral switching. These types of drugs have also different pharmacokinetic and pharmacodynamic properties. Pharmacokinetic properties are based on the effects of drugs over time, and pharmacodynamic properties are based on the mechanisms in the chemical structure of drugs. These properties can also affect how each of the isomers won't be able to work correctly based on its different three-dimensional structural arrangement. This is also associated with the lock and key mechanism, which can create devastating effects to the body as a result. An example of optical isomers which have had different chemical and therapeutic properties includes thalidomide. This is a racemic drug containing equal amounts of left and right-handed isomers. The S isomer is an effective sedative. However, when the R isomer was used in the late 1950s to treat morning sickness, the manufacturers had failed to carry out adequate testing for its safe use in pregnancy. As a result, they lacked an understanding of how enantiomers were converted inside the body to each other, resulting in both isomers becoming teratogenic, affecting fetal development. This can lead to birth defects such as thocomelia, which results in children being born with very short limbs or no limbs at all. Thalidomide is known for having anti-angiogenic properties, which involves a lack of growth of blood vessels. When testing for ROS or relative oxygen species, it can be indicated by using 2,7-dichloro-dihydrofluorescein diacetate. Thalidomide can be inhibited by either mannitol or 2-mersattoethanol, which are classified as hydroxyl radical scavengers. This means that they protect the cells in the body and thus allows an increased number of blood vessels to develop in embryos. As seen from the diagrams illustrating the isomers of thalidomide, they are both comprised of nearly identical arrangements, each of which are shown as opposite mirror images. This classifies them as optical isomers. Optical isomers are when molecules are non-superimposable and have asymmetric carbon bonds with four different groups, which create mirror images, and can only rotate the plane of polarized light either clockwise or anticlockwise, as they can be positive or negative enantiomers. However, since these enantiomers of thalidomide are of equal concentrations, they would be classed as a racemate mixture. The only difference between both enantiomers lies between the chiral center found between the bonds of carbon-nitrogen and carbon-hydrogen, as seen in the red circles. In this part of each diagram, the bond has been shown to have three-dimensional depth. This is because the S isomer located on the left has the carbon-nitrogen bond shown as if it was positioned outside the dimensions of the paper, while the carbon-hydrogen bond is shown as if it was positioned inside the dimensions of the paper. The exact opposite can be seen from the R isomer located on the right, where the carbon-nitrogen bond is shown as if it was positioned inside the dimensions of the paper, and the carbon-hydrogen bond is shown as if it was positioned outside the dimensions of the paper. As mentioned on a previous slide, through defining the lock and key mechanism, i.e. each enantiomer is specific to the precision the of every other arrangement of enantiomers. This means that despite the near identical structure of both the S isomer and the R isomer share, the difference in the chiral center is what stops them to match up correctly and cause the same effect. Therefore, the S isomer is an effective sedative while the R isomer affects fetal development. Here are the references which have been used to help explain the chemical and therapeutic importance of isomerism. Thank you for watching.